Hello, welcome to this primer on machine learning for neurosurgeons. Doctors from other fields might also find this presentation useful. This is Dr. G. Narenthiran, neurosurgeon from Bristol. The essence of machine learning is to use computers to figure out patterns in data and do it so quickly. Let us first review how a traditional computer system works. Let's say we want a computer to make soup. With a traditional computer system, we have to input the recipe and the exact instructions to the computer. Then the computer would make the soup that we had expected. However, now let's look at how a machine learning system might deal with making a soup. In machine learning, the computer would review several videos and even read cookbooks on how to make a soup, and then from analyzing these videos and books and the outcomes, it would then come up with a soup that it thinks is the best. Now let's schematically review the traditional computer concept and machine learning concept. In traditional computer concept, you would input data and a program. The computer would process them and produce an output. However, in machine learning, you would input the data and output from historical findings. The computer would then try to pick a pattern using machine learning algorithm and output a program. You can then use the program to make future predictions. Machine learning is not new. Even when I was a 10-year-old lad back in the northern Sri Lanka in Jaffna, I heard about neural net. Machine learning is now in vogue mainly because of the availability of powerful personal computers, user-friendly machine learning software, and several algorithms for affecting machine learning. Another reason is many vendors, including giants such as Microsoft, Apple, and Google, and NGOs such as Slovenia University, are making sophisticated and user-friendly software which allow you to implement machine learning for free. Machine learning is complex. However, you can nowadays go a long way without the need for a mathematician or a computer expert. If you would like to make the algorithm specific, tailor-make it, then you would need a mathematician. If you want to make the machine learning model incorporated into a sleek interface on a desktop, mobile or web app, then you will probably also need someone with computer expertise to connect the model to the interface. There are two main types of machine learning. They are supervised and unsupervised. The difference is based on whether the model needs training data and training or not. Supervised machine learning requires training from historical data that includes variables and outcome. The unsupervised machine learning does not require training. There are two subtypes of supervised machine learning. They are regression and classification. With regression, the output is a number, numerical. With classification, the output is categorical groups. The options for unsupervised machine learning are more limited. Unsupervised machine learning is mostly used for clustering outcomes into subgroups. Now, let's look at how we could use regression in craniofacial surgery. Children with sagittal craniosynostosis have narrow, long heads. Narrow, long heads is called scaphocephaly. Cranial index is the ratio of the width of the head to its length. Cranial index is checked before and after the operation to assess how much the shape of the head has changed. Cranial index is a number, so this is amenable to be an outcome in a regression machine learning model. However, as regression machine learning model requires training, we need to input historical data on relevant variables such as age at operation, type of operation, pre-op cranial index, etc., and outcomes of those respective operations. Then the software could use different algorithms to come up with a machine learning model to predict post-op cranial index for future cases. There are many algorithms available. Examples are random forest, logistic regression, neural net. You would need to decide which algorithm is best at predicting from test data that you have not used previously for training. A classification machine learning model would be for facial shape recognition, an algorithm that rates the shape of the head. To do this, you would need to initially train the model with photos of head of children and the average score from, let's say, 10 raters. These are then input into the computer running the machine learning software. This then produces a model. You could then use this model to objectively score head shapes of future post-op patients rather than needing 10 raters for each future case. Now, let's look at possible application for unsupervised machine learning. As we mentioned earlier, unsupervised machine learning does not need training. Let's say that you have operated on 100 children with scaphocephaly. There is a variation in the post-op cranial indices. It would be good to figure out whether we can find subgroups based on inputs and the output. This type of clustering could be used to develop grading systems. Currently, there are many softwares out there to help with developing machine learning models. Many are free and others are commercial. Let's look at some of the free machine learning software out there. All Mac computers can use machine learning. If you download the Xcode, which is free, then there's a module called Create ML. This is the Mac's own native machine learning software. Another excellent and free machine learning software is Orange Data Mining Software. This is from the University of Slovenia. It has Mac, Windows and Linux versions available. There are also excellent tutorials on this on the YouTube. It is powerful and it is very user-friendly. Microsoft also has a free software called Microsoft Azure Machine Learning Studio. Python is a free computer programming software, and you can download machine learning modules which are free as well. The Python systems are very powerful. However, you will need to know basics of Python programming and how to incorporate the machine learning modules into Python. If you are interested in using Python, then the book by Wei-Ming Lee, published by Wiley, called Python Machine Learning would be an excellent starting point. The commercial machine learning software I have used are ExcelStat and MATLAB. ExcelStat is user-friendly but relatively expensive. You could buy it with some discount if you have an academic affiliation. However, it will still cost you a round trip from UK to America. However, it does not allow image or photo recognition technology. It is useful if the outcomes are numerical or categorical, and it does allow for clustering analysis. MATLAB is a very powerful mathematical software, and with its machine learning and deep machine learning modules allow you to execute very powerful machine learning algorithms. These will include every type of machine learning. The Mac version of the FileMaker Pro 19 database software allows you to incorporate machine learning model into your database. So when you put the relevant inputs in the fields, the machine learning software that's incorporated into that database that you had previously developed makes a prediction and enters the prediction in a separate field. This is a very elegant solution. It only works on the Mac version of the FileMaker, not on the Windows version. If you are interested in learning machine learning, I would definitely recommend you to visit the tutorials on Orange data mining software in YouTube. The tutorials are bite-sized and they are excellent. They will make you into quite an expert in machine learning. In this presentation, I have only touched on the very basics of machine learning. Machine learning is a useful tool for doctors. It could provide novel solutions to problems until now seemed too complex to untangle. Machine learning is within the reach of doctors. I hope you found this presentation useful. Thank you and wishing you a good day. Bye for now.